Okay, so we'll start with collision. So conservation of linear momentum, you already know about it. What is conservation of linear momentum? Okay.
Did that in this, right? NLM.
Yeah, we already studied that conservation of momentum. So we are not going to study it in deep here. If you have any system, okay, so its momentum is always conserved. Like if you are firing a bullet, then your bullet and gun, what is the momentum before firing?
MV.
It is zero, because bullet is
Okay, before firing zero.
before firing its momentum is zero for both the systems, and after firing your bullet is going forward and your gun is backward.
It will be mass of bullet into velocity of bullet minus mass of gun minus velocity of gun, right?
Yeah. So if let us say before collision its momentum was zero for both the bullet and that one gun. After the firing, let us say mass of the bullet and it is the velocity of bullet plus mass of gun and velocity of gun. Okay.
It should be minus, right? Because the velocity would be in opposite direction.
It will be in minus, yaar. Keep your patience. So before collision it was 0, after collision it must be 0. After firing it must be 0. So that's why it becomes MBVB minus, or we can say equal to minus MGVG. Okay. So their momentum is equal and opposite. So that's why your gun is having the same momentum of recoil whatever is your bullet is having. Okay. So that is the concept, but I don't think we should waste our time here to got it. So in every question you need to just, what will be about kinetic energy?
It will only be conserved.
See, kinetic energy of the bullet will be more rather than kinetic energy of the gun. Okay. Why it will be more? Because bullet is also exploding. There is explosion in that bullet. Okay.
This velocity would be more.
Yeah, velocity will be more. Why? Because that is also providing energy to the bullet.
But when the gun's mass be more?
Yeah, gun's mass is more, but ideally that should be equal for bullet and gun. Okay. But that is not, practically it is not equal. Why it is not equal? Because bullet is exploding. Okay, so that is having another energy stored in that in terms of explosion. So that energy is given to the bullet.
1 second. So for momentum, how will momentum be conserved if the velocity of bullet is more than the gun?
Yeah, that same recoil will be there. Okay.
So then wouldn't the kinetic energy be same as well if the same recoil is there?
Yeah, it will not be same because masses are different. Kinetic energy depends upon masses as well.
But even momentum depends on this.
Yeah, momentum depends on mass and velocity. Kinetic energy is also depending upon mass and velocity, but just I am telling you, it will be slightly greater than the kinetic energy of the recoil.
Okay.
Okay, because it is exploding. So because of explosion, it gets extra energy. Okay, just keep it in mind. Okay, so that chemical energy of gunpowder is converted into kinetic energy. Okay, so that energy is only given to the bullet, not to the gun. Okay. Now, if it is a block system, again I am telling you, this is also the simple thing. Okay.
We'll only take friction into consideration.
Yeah.
That's the only difference.
Yeah, we already did it in NLM. portion. Okay.
We just subtract the value of force of friction.
See, in any of the scenario, you want to keep two things in mind, that before collision, what was its momentum? After collision, what is its momentum? So keep both momentums equal. Okay. Another thing, before collision, what was its kinetic energy? After collision, what is its kinetic energy and potential energy? See, before collision and after collision, entire energy is going to be same. Okay. So before collision, it was having kinetic energy plus potential energy. Okay.
But I thought it was simply academic. You can't use kinetic energy conservation in every case, right?
Yeah, kinetic. I'm not talking about only kinetic energy. Energy will be conserved. Okay. So
But how will we know the energy that is lost by heat or by some whatever?
energy will be either it will be kinetic energy or it will be potential energy. So you just add these two before collision and add after the collision. So that will be same.
Okay, so we can always use conservation of momentum and conservation of energy to solve these sums.
Yeah, yes. That is the main motto. Okay. And always take your horizontal momentum, compare horizontal momentum with the horizontal one. Okay. If it is not,
Can you repeat it?
yeah, take horizontal momentum with horizontal one. Okay. Because if you are comparing horizontal momentum, so horizontal momentum will remain same. That will be conserved.
We can't compare it. If it moves up, then we can't compare it.
See, there may be scenario that your collision is head to head. Okay. That means it is having only linear momentum. Okay. That is going horizontally. But situation may be arising that it is not head to head collision, it is some slightly with angle.
Yeah, then we can't use conservation of momentum.
You can use conservation of momentum, but in that case, you will be having two components, that is horizontal component and vertical component. So you will take
For the bottom one.
for everyone, this one.
Yeah, exactly.
Okay, and after collision, that body will also go. That body after the collision, that body will also have horizontal velocity as well as vertical velocity. It will be having two components. Okay. So just keep in mind that you have to compare horizontal with horizontal and vertical with vertical. Okay. So you can't mix it up. Okay. If the bullet is also emerging out, then also momentum and energy will be conserved. Okay. And in case of bomb also, let us say there are three components of bomb. P1 is going in this direction, P2 is going in this direction, and P3 is going into this direction or this direction. Okay. So what you have to do here, all the momentum is 0. Okay. But you need to keep in mind that you need to compare only horizontal with horizontal, vertical with vertical.
Initial horizontal momentum with final horizontal momentum.
Yes.
Initial vertical momentum with final horizontal.
Yes. That you want to. Okay. Now it is about motion of two masses connected to a spring. Let us say the same principle will work everywhere. Okay. Let us say two masses M1 and M2. They are connected with a spring. So if you are stretching it or you are just compressing it, so you are giving an extra force. Okay. So that force, that means you are doing some work. That work will be stored as an energy into that system. Okay. So what that extra force will do? Both the bodies will be in motion then, isn't it?
Yeah.
And so in that case also, initially both the blocks were at rest, so what was their momentum? P1 plus P2 equal to 0. Okay. Now, once they will be in motion, then what will happen? Because as you are applying the external force, so they will be having the same momentum, but in opposite direction.
Yeah.
Oh, isn't it? Got it?
Yeah. So, can we apply these concepts to any dimension circular motion as well?
Yeah, every time your momentum and energy both are same, both are conserved.
Provided we have those values, we can always apply it.
Yes. Okay. In vertical motion also, conservation of energy concept is used. Okay. Because as the body is gaining height, so what is happening? As it is going up, its kinetic energy is reduced, but its potential energy is increased. At the highest point, its kinetic energy is 0, but
Potential is greater.
potential energy is maximum. As it go down, then potential energy is decreasing, but what is happening? That potential energy is converting into kinetic energy, and at the lowest point it is having maximum kinetic energy. Okay. So you can compare it with every movement. What is the kinetic energy at this point? What is the potential energy at this point? But some will be the same. Okay. So in this case, their momentum will be opposite and equal. Okay. And kinetic energy will not be equal. Why will not be equal? Because kinetic energy will be P square by 2m. Okay. If they have different masses, then what will happen? If you compare it, then kinetic energy of 1 with kinetic energy of 2 will be equal to m2 by m1. If m1 is lesser, what will happen?
Yes, sir.
Then it will be more than 1.
Yeah.
And even kinetic energy of first block will be greater than kinetic energy of second block.
1 second.
Okay.
No, sir. Kinetic energy should also be conserved in this case.
See, initially kinetic energy of the block is 0 as both are there, but after some time kinetic energy of the blocks is not 0. Why it is not 0? So kinetic energy is not constant but changes here during the motion of the, it is also converted into elastic potential energy. Okay.
That's the reason.
Yeah, that is the reason, because before starting its motion, so kinetic energy during each time will not be same because of elastic potential energy. Once you are compressing it, it has only elastic potential energy. Okay. Once you release it, what happens? That elastic potential energy converted into kinetic energy. Okay. And as time elapses, what happens? Elastic potential energy is reducing and kinetic potential energy is, okay. So that will affect its, so kinetic energy plus potential energy will be equal to mechanical energy, and that will be constant.
This was a case in which the objects did not have a spring between them, they were just moving closer together. Then kinetic energy conservation could be applied, right?
Yeah. Okay. So it is not about the kinetic energy, it is not about the potential energy, but energy will be constant. Okay.
Yes.
So you need to think how many types of energy it has. So just add all these energies before and after that will be equal. Okay. Okay, so these are simple questions. I think you can easily do that questions. So I am not talking about these questions. Okay, just try it. You will be able to do that. Okay, just try to do this. Illustration number 13.
Momentum is always conserved, right?
Yes. Okay, just try to do this. Are you getting some background noise as well?
Yes, some people are speaking in the mic, I think.
Because that my house next, Ravan Dahan is there. So the whole society is there at my gate. My house is at corner. Is it the too much?
No, sometimes it's too much, but most of the time it's like very soft. It's
Okay,
like
okay,
very soft.
okay. Just do it very fast because we have to cover more topics. Okay.
Yes, sir.
Okay, what will be the net force after releasing it?
The net force,
Net force would be 0 because the same force A will apply to B and B will apply to A.
can it be the same force?
Force will be same. If force is different, then what will happen? That spring will break.
But how will it be the same? One is moving with 15 meters per second, the other is moving with 10 meters.
Yeah, so lighter one will go high with higher speed.
Yeah, but we need to find the mass for that, right?
Mass is not required. They are given that means it is lighter. That B is lighter because it is moving with the greater velocity. Okay. So always net force will be 0. Okay, if net force is 0, so its center of mass will not move. Okay, so the first one will be right answer. Got it?
Okay, is it because those two are released and no external force is applied on them?
Yeah.
That's why the lighter one will start going with the faster speed as compared
Yes, lighter will always be faster.
to, unless there's a separate force applied on the heavy.
Yes.
Okay, that's fine.
Okay. So rest all questions you just try to do at your own. So we'll cover the concepts only. Collision. Collision, as you are already aware. So I'll take some scenarios. Okay. These two scenarios you can see here. It is called direct impact. It is called oblique impact. I told you all the scenarios. In direct impact, there will be only linear momentum. Okay?
Yeah.
But in oblique impact, there will be two components. The one will be vertical and one will be horizontal. So horizontal will be compared with horizontal only, vertical will be compared with vertical only. Okay?
This one, in this way, this one we also use conservation of momentum and energy, right?
Yes.
In
Okay.
entire collision and central passing, we use those two.
Yes. So now, if it is head on, that means direct impact. So what is happening actually? See, these three scenarios will happen. Okay. Let us say B is moving in this direction, A is also moving in this same direction. So if they are colliding with each other, instant when impact begins. So it is instant when impact begins. Now what happens, as your A is having higher speed, so it is the deformation period. It will deform. Okay, it will press, isn't it?
But how do you know A has a greater speed?
That only then it will be colliding. If A is not,
Okay, so yeah, then
if A is having lesser speed, how it will catch that B? Okay, so either that B is in stationary condition, then only A will collide. Okay, so this impact, so that period is called as deformation period. Okay. So when impact begins, so that is the time in which deformation is taking place. Okay, and again that will be a restitution period in which it will again into the same shape. Okay, so instant when impact ends. So this is the time when impact ends. Okay, so these are three scenarios we'll talk about. So before collision it was having certain momentum. After collision it will have certain momentum, so that momentums will be equal before and after. Okay, that is simple, I think. Okay, so the time interval during which deformation takes place is called the deformation period. So this is called as deformation period, and again the time taken to restore its original shape, so that is called as restitution period. Okay. Okay, so in this scenario what is happening, they are moving with different velocities, but at this time they will be behaving like a single body, isn't it? So they will be moving with the same speed. Okay, is that understood?
Yes.
Any doubt? Easy?
Yeah.
Okay, just a moment. Okay. So that is called restitution period. Okay, equation of impulse and momentum during impact. So that is nothing, I will not go in much detail. Okay, but you have to keep in mind that before collision and after collision momentums will be same. Okay.
Yes.
So conservation of momentum during impact. that will be MAUA plus MBUB will be equal to MA plus MB. It is during impact. Okay, because during impact that will behave like a single body, so they are moving with u velocity. Okay,
Okay. No, shouldn't it be 0?
why it will be 0? Before collision as well they were having some momentum, both were moving.
Yeah. So MAUA is the initial velocity, initial momentum of A.
Yes.
And MBUB will be the initial momentum of B.
Yeah, and at the time of impact they will be moving with the same velocity.
Yeah.
Okay, so at the time of impact before collision and at the time of impact momentum will be same.
Yeah.
Okay, so that is the equation, that MA plus MB into U equal to this one. So from equation 4 and 5 we obtain the following equation. So that is also equation after collision, that is equation after collision. So after collision momentum will also be same.
Yeah.
Okay, now coefficient of restitution. You know what is impulse?
Yeah.
If it is force into time. Impulse is force into time. So what will be the impulse of see, the one will be deformation. Let us say D force is used at the time of deformation. So what will be the impulse? It will be D dt. D is the deformation force.
Impulse is equal to force into time, right?
Yeah.
Why did we integrate it?
Integrate means it is because time is having certain limit. Okay.
Yeah.
So that's why we have put it integration. Whenever we have a range from this one to this one, we integrate it.
Okay. And it's dt because it's a very small interval of time.
Yes. Okay.
And integrate to find the range.
Yeah. So that will give you the entire impulse during that particular moment.
Okay, it will gather, it will like add.
Yeah. Integration always gives you addition.
Area.
Okay. So d dt, d is the deformation force, r is the restitution force. So we can find the impulse. But what is that? The coefficient of restitution. Coefficient of restitution is impulse of recovery, impulse of deformation. So if we divide these two, we will get the coefficient of restitution. Okay.
Yeah.
So that will be given as, so E will be given as VB minus VA, that is the magnitude only, because they have used so that is only magnitude. So VB minus VA upon UA minus UB. So that is called as coefficient of restitution. Just note it down because it will
So
be.
why did you first do VB minus UA, the second time did UB minus UA? UA minus UB, sorry.
That doesn't have any problem. If you write VB minus VA or you write VA minus VB, as it is a mode, okay. So either you write VB minus VA or you write VA minus
Okay, so
VB.
will anyway turn it into positive.
Yeah, that is only the difference. So that is the difference in A and B bodies velocity after the collision. Okay, that is the difference in both the bodies velocity before collision. So you just need to take the difference in velocity after and before the collision. So it is just a ratio. Okay,
Okay.
got my point?
Yes.
Now things is perfectly elastic or inelastic impact. So for inelastic impact your E would be 0.
Inelastic.
Okay. Elasticity means what? Elasticity means it is compressible. Okay. If it is not compressible, that means it is not elastic. Like an iron ball. If you have an iron ball, so what happens if you press it? It doesn't press.
Yeah.
Okay, so it is, you can say it is just inelastic. Okay, but perfectly nothing is inelastic, nothing is elastic. Okay. So for inelastic impacts, your E would be 0, and for perfectly elastic impact, E would be 1.
Why would it be 0 for inelastic?
Body undergoes impact stick to each other after them because they will be having the same velocity.
What's E in this case?
What is E? E is VB minus VA. So if both bodies are going with same velocity after collision, what happens? The difference would be 0.
Yeah.
So that's why your E will be 0 in case of inelastic impact.
What about elastic? Why would it be 1 for that? Shouldn't it be 0 for that as well?
In case of elastic impact, your E is 1.
Shouldn't it be 0 for that as well?
Because the difference would be same before and after collision. Velocity difference will be same. Momentums will be same. Okay?
I don't understand.
See, two bodies are coming.
Yeah.
So, after collision, if they are perfectly elastic, so whatever momentum this body is having, that will be going with the same momentum back.
Okay.
Okay, and this body will also be having the same momentum. So speed will be same before and after collision.
You saying no energy will be transferred from each other to any of them?
Yes.
No energy from A will be transferred to B and no energy from B will be transferred to A.
Yes. So in that case, velocity is difference after the collision and before the collision it will be same.
So VA would be equal to UA and VB is equal to UB.
No. Yes, you are right. VB minus VA, whatever is the velocity difference after collision, before collision, whatever will be the difference, after collision, that difference will be same. Okay?
Yeah.
So, in that scenario, it is called as perfect elastic collision, and perfectly elastic collision will have E value as 1. Let us say two bodies are coming. So, whatever was the speed of this body before collision, okay, so this A body is coming, B body is coming, they are coming with certain velocities. So after the collision, they will be having the same velocity. Okay, so that is called as perfect elastic collision. Okay, got my point?
Yes.
Okay, so these two conditions will be used. It is the momentum before collision, it is the momentum after collision. Okay, and coefficient of restitution will also be given to you. So that will be VB minus VA equal to E into UA minus UB. So just write down these two things because they will be used in solving the question.
There's like, it's possible that it's not perfectly elastic or inelastic.
Yeah, that's why E is given. What is E? E is the coefficient of restitution. Okay, if it is perfectly elastic, E will be 1. If it is inelastic impact, then E will be 0. Okay. So these two concepts, conservation of momentum and coefficient of restitution concept, these two concepts to be used to solve these questions. Got it?
So I need to open the door.
Yeah, please. Okay.
What should I write?
Yeah, these two things you just have to remember that these two concepts will be used once we are doing collision problem. Okay. Now, types of collision according to the conservation law of kinetic energy. Each law will be discussing here. So, elastic collision, what happens? Before collision and after collision, kinetic energy will be same.
Yes.
Because the speed is not going to be different before and after collision. Okay? Whatever speed A was having before collision, after collision it will be having the same speed.
Okay.
Okay? So there is not going to be changed in the term of speed. So their kinetic energy will be same before and after collision. Got this point?
Yeah.
Okay. If it is an inelastic collision, so kinetic energy is not conserved. Okay? Because some type of deformation is there, so some energy lost in collision, therefore kinetic energy before collision is greater than the kinetic energy after collision. Okay? Got my point?
Yeah.
Okay. Now perfect inelastic collision, both the bodies stick together after collision. So what happens? Momentum remains conserved in all type of collision, but momentum is always conserved in each type of collision. But kinetic energy is not conserved. Okay?
Will it be considered perfect and elastic?
Yeah, perfectly inelastic, there will not be kinetic energy will not be conserved because it is going to be changed in some terms of deformation.
Okay.
Okay?
Wait, won't it be deformed in elastic as well?
Yeah, it will be deformed. If
But
it
then
is
how
an
did it
if it is an inelastic collision, that will be deformed. Some bodies will be deformed.
No, it will be deformed in elastic as well, right?
No, inelastic they will not be deformed. Elastic means what? They will touch each other and they will detach. Okay? Like you have rubber ball, so you just dropping it, so it again covers certain height. But what happens if you drop that iron ball?
Just fall to the ground.
Yeah, it will be deforming the floor, isn't it? So that energy will be lost. Some energy will be lost. Okay. But in case of rubber ball, that will energy will not be going to lose. Okay. Got my point?
Yes, sir.
So this is just an idea about types of collision. Now we already talked about it. Okay. So if it is an head-on elastic collision, then before collision, during collision, after collision, kinetic energy is also going to be same. Got it? So you need not to remember these formula. Okay?
You can derive that.
Yes. You always just try to solve questions with the concept only. Okay? Then it will be good if you solve it by concept. Got it? Now it is a bouncing of ball. You can remember these concepts, these formulas. Okay? If it is bouncing ball, then its velocity after each and every bounce, its velocity will be decreasing. Okay? Got my point? So what will be the velocity after each and every bounce? That will be equal to e to the power n 2gh. Okay? So this formula will be used for velocity immediately after nth rebound. So velocity immediately after nth rebound, question will be asked that you have drop an elastic ball. So what will be its velocity after fourth rebound? Okay. So height will be given to you and they are asking you about the fourth rebound. So n will be given to you. So you can find out the velocity after fourth rebound, fifth rebound, sixth rebound.
But how is this V is equal to root 2GH?
See, this is not the time because you have tomorrow exam.
Okay.
Okay.
So which formula should I remember? Vn is equal to En V or Vn?
Vn equal to e to the power n 2gh square root,
Okay.
where
And Vn is
n is the bound. Okay, n is the number of bound.
velocity after fourth bound. For
Yes.
example, if n is
So
4.
n will be 4 and height, whatever was the height. Okay.
And what will be En would be the coefficient of restitution after fourth bound if it's 4.
Yeah.
After nth bound.
Yeah.
Basically.
That is going to be same every time.
Why would it be the same?
Yeah, because you are using the same material. If it is a rubber ball, so the rubber ball is always bouncing. So that
It will use the same amount of energy to the ground.
yeah, the coefficient of restitution is not going to same. What is the coefficient of restitution? Right? That is the coefficient of that ball.
Yeah.
So in each rebound, ball is not changing. Ball is the same. So your coefficient of restitution is not going to be changed.
What
Okay.
exactly is restitution? Understand the formula Vb minus Va divided by Ub minus Ub. What is it?
Which one?
What is restitution exactly?
Restitution means it is a property of body to gain its shape and size again. If you apply a force on a rubber ball, what happens? As you release the force, it again goes into the same shape and size. Okay, so that is its property. Restitution is a property of that body to gain its shape and size again after releasing the force. Okay.
When we do Vb minus V and Ub minus divided by Ub minus V, we basically find the force which is being used by it.
Yes. If it is a collision of two bodies, then we are talking about impact. Whether it's a plastic impact, whether it is an elastic impact. Okay. If you have a rubber ball and another is a ball of mud, what happens? It will be a plastic collision. Okay. Because shapes of the mud ball is not going to be regained. It will be deformed. Okay. So if two rubber balls are just colliding with each other, then it is an elastic collision. Okay. So these things you have to consider. Now height. The same formula will be used. Okay. See, this is only formula. You can find its velocity after first rebound. Okay. Height will be given. From a certain height, the ball is dropped. So, if it is talking about V2, so what is happening? V2 will be equal to e to the power 2 2g h1. h1 is the height which it gains in first rebound. Okay. Because height will be different in every rebound. Got it?
So what we'll do is basically cube, for example, the third rebound, then we'll cube the coefficient of restitution which we found initially, and then we'll do it multiplied by root 2gh.
See, what is V1? V1 will be EV.
Yeah.
And what is V? V is 2gh1. V1 is 2gh1 and V is 2gh. So h1 will be E square h. So it will be easy if you just remember this concept that hn will be equal to e to the power 2n h. Okay. So it all.
What is h in this case? The height after the first bound.
Yeah.
H
If you put
height after the nth bound.
if you put n as 1, so that will be height after first rebound.
Okay, which would be equal to e to n h.
Okay.
Okay.
Now this time, so time formula is again this one. Time is in terms of t, you can remember it. T is what? T is the time it is taking in the this time is t1, in which time it is coming from here to here. Okay, that is t time. So time taken to make its impact in first drop. Okay. So Tn, you can remember that formula also. So total time taken in bouncing. So let us say it will be total time taken in bouncing. So that will be given by 2h by g into 1 plus e upon 1 minus e. Okay. If you add all these distances, you will find the total distance it covered before it stops. Okay. So that is h plus 2h1 plus 2h2. Why it is 2h1? After rebound, it gains height h1 and again it drops its height h1. So how much height is covering? After first drop, it is covering h1 as up, h1 as down. So that's why it is written as 2h1, 2h2, so on. Okay. So what is 2h1? 2h1 is 2e square h, and that is an exponential series, 1 plus e square plus e to the power 4. So that is that is GP, geometric progression. Okay.
Yeah.
So if we do it up to infinite, so we'll have 1 over 1 minus e square. So finally we have s is equal to h into 1 plus e square upon 1 minus e square. Okay. What will be the average speed? If you divide total distance covered by total time, you will get average speed. Okay. Average velocity, if you find total displacement upon total time, so total displacement is h and total time, that is the total time, so that will be the average velocity. Now I was talking about oblique collision. In oblique collision,
So, but I have one question to the above ones. To find the coefficient of restitution, don't we need the velocities? Don't we need two velocities?
that will be given. Coefficient of restitution will be given to you.
Or they will give us the two velocities.
Yes. If it is a collision of two bodies, then you can find coefficient of restitution by just comparing the velocities before and after collision.
Or they will give it to us.
Yes. Okay. If it is a single body, so if you are dropping that ball, so ball's material will be having coefficient of restitution. Okay. So that will be given to you. So you can simply put it here. In oblique collision, I told you, you just have to compare horizontal momentum with horizontal one, vertical momentum with vertical one. Okay. So before collision, your horizontal momentum will be equal to the horizontal momentum of the bodies after collision, and as it is the case of, or you can find it vectorially also. Okay.
Okay, so we need to but for oblique collision, so basically compare the for first case, like when it's not collided yet.
See, it's a free body diagram, and in a free body diagram, as your momentum is a vector quantity, so momentum, as it is a you can imagine that whatever is the direction of momentum to the left side, whatever is the direction momentum to the right side, just add these, they will be equal. Okay, because it is a vector. So you can solve it vectorially also, and you can also compare it through conservation of momentum.
The vertical component would be 0 initially, right?
Yes. No,
So
it will not be 0 because it is a oblique collision.
No, but initially it is 0, right?
No, it will not be 0 initially. Why it will be 0? If one body is here, another body is impacting like this. So this body is having two components. vertical and horizontal. Okay, let us say this is moving in horizontal direction, but this is moving in oblique collision. So it will have only horizontal momentum before collision. Okay, but this body, whatever is coming obliquely, so that will have both momentum, horizontal as well as vertical.
But in the diagram, we can only see the horizontal component. Can we look both of them moving horizontally?
This body is oblique, M2.
No, but this is what it is initially, right? The left part. That's what's happening initially, and we're moving in horizontal direction.
Whatever is the scenario, just remember the momentum before collision and momentum after collision will be same.
No, I don't know. Maybe I knew that, but what will I take the initial vertical component for momentum? That's what I got.
If it is an horizontal movement, then vertical component of this will be 0. Okay, but if this body is moving like this obliquely, so that means it is having both component, vertical as well as horizontal. Okay,
But how will they be vertical movement in this case? I don't understand.
see, its vertical component will be 0 because it is moving in the horizontal direction. Okay, and this body is moving, this body is having
There's
two
no
components.
body moving like that. That's the issue, right?
Yes, that is depending upon the scenario. What scenario is
In
given?
this scenario, how is it moving obliquely? There's nothing moving like that.
See, you can see here, impact is here. It is not at the center, isn't it? So before collision, their momentum was only horizontal. Okay?
So in this case, it is 0, right? The vertical component.
Yeah, vertical component is 0 in this case.
Okay,
Because
yeah, that's what I was asking.
yeah, because they are moving in horizontal, they are moving horizontally, not vertically, not obliquely. So that's why their momentum will be they will be having only horizontal movement, nothing vertical movement will be there. Okay, got my point?
Yeah.
Horizontal component you will keep it equal to the vertical component after, horizontal component you will keep it equal to the horizontal component after collision. Got my point? What about vertical component? The sum of vertical components will be 0 because before collision it was 0.
Yeah.
Okay? Got it or not?
If it was going obliquely from downwards, then we would need to find the components
See,
of that as well.
you can see here, along y-axis, that means vertical component, it is 0 plus 0 because they were not having any vertical movement. So their momentum is 0 before collision.
Yeah.
Okay, after collision, it is a vector diagram because one is going up, another vector is going down. So how to add these two vectors? Just have to have negative sign in that. Okay?
Okay.
And by conservation of kinetic energy as well, you will also keep this in mind that energy, the kinetic energy will also be going to equal. Okay? So these two concepts will be used whenever you will be having a collision type problem.
So this is elastic collision because kinetic energy is being conserved.
Yes. If they are equal masses, these are scenarios not to discuss, these are very simple. Okay?
So how do you know that it's going to be an elastic collision?
That will be given here.
It's not given as in questions. It's not
Questions,
given
in
as-
questions your E will be given. See, just you have to remember these things. Linear movement, find out the final velocity, that is very simple. The thing is given that they are perfectly elastic. Perfectly elastic means E will be going, E value you will be having 1. Okay? Got this one?
Yeah.
Is there any difficulty?
No.
Okay, I hope you can do all the questions.
Let's discuss one question.
Hmm?
Let's discuss one question.
Okay. Which one you want to discuss?
There are more questions down as sir.
Hmm?
There are bottom there are more questions. Exercise 1, exercise 2, exercise 3.
These are simple questions. If you know the concept, you can do it very easily. Okay? I hope now you will be able to do all the questions. If you know the concept, then it becomes very easy to solve questions.
It will only be elastic collision if the coefficient of restitution would be 1.
Yes. And
1 second, sir. What about perfectly inelastic at that? 1 second, can you go to this? 1 second, can you go to that page number? Can you scroll up? It is before this. Before this one. Yeah, this one. No, above this, sorry. Just above this. Perfect. Where there we can. Yeah, this. What's perfectly elastic or inelastic is that?
perfectly elastic means as you have ball, a rubber ball, as you compress it, again it is going into the same shape as you just remove that force, isn't it? So if it is going into the same shape after removing external force, then it is said to be the perfectly elastic body.
No, but the problem is they have given perfectly elastic is 0 and perfectly inelastic is 1. They've written it in both of them, look. Perfectly elastic or inelastic impact is equal to 0. Perfectly elastic impact is equal to 1.
Perfectly elastic means if two balls are coming with some velocities, so after impact they will be going with the same velocity.
Okay.
Okay, whatever was the incoming velocity, that will be going with the same velocity.
Okay.
Okay, so in that case your E would be 1, because what is V, what is E? E is VA and VB difference over UA and UB difference.
Yeah.
Okay, so if they are going with the same velocity, then the difference will be same.
Okay. So basically, for elastic collision, in those cases we can use E would be equal to 1.
Yes,
For elastic.
if it is given that it is an elastic collision, then you will say always it is E equal to 1.
Yeah. And we can use either kinetic or momentum conservation.
Yes, in elastic collision, it only works in elastic collision.
And there's nothing.
And see,
our syllabus is
conservation of momentum also holds if it is a perfectly plastic or inelastic impact as well.
what's a perfectly plastic one?
Perfectly plastic means it is not going to be having into the same shape. Like I told you an example, if you have mud ball, if you have a rubber ball or iron
Okay,
ball.
so we can just call just inelastic.
Yeah, it is not going to be gaining its the initial shape.
Okay, so basically we can just call it inelastic collision.
Yes.
Not perfect in which it stick. It will just be inelastic.
Yes.
Will it stick in plastic? No, perfectly plastic. Will it stick together?
Yeah, plastic and inelastic both are same.
Plastic and perfectly inelastic are same.
Perfectly plastic or inelastic. plastic and inelastic both are same.
Okay.
Okay.
But perfectly inelastic is different. Can you
Perfect.
write the values of E for all of them? Perfectly inelastic, elastic, and inelastic.
Perfectly inelastic or perfectly plastic both are same thing.
Okay.
Okay.
Okay. And for them, E would be equal to 0.
Yes.
For perfectly elastic, E would be equal to 1.
Yes.
And for perfectly inelastic, we need to find the value of E. There's no fixed value for it.
Yes. Okay.
And in E, they
But
will
but
not
but most of the questions will be given on perfectly elastic impact. Okay. I hope you will be able to understand now.
No, sir, I don't have that. Perfectly inelastic collision has written that both bodies stick together after collision. And for just inelastic or plastic, they also written they stick together after impact. How is that possible?
Where it is written?
For scroll down and for perfectly inelastic, no, below that they have written that for in perfectly elastic, yeah, it's the C point over there. Yeah, perfectly inelastic, both bodies stick together after collision.
So that's what I am telling you. Perfectly inelastic collision means you have a mud ball, you have a
No, I understood that. I understood what you had explained.
they will after collision, what will be happening? They will be stick together and they will be going with the same as a single body. They will not bounce back. Okay.
And for what about plastic?
That is the same.
So what's the difference between
It is
both?
nothing. Yeah, plastic and inelastic both are same terms.
No, plastic and perfectly inelastic.
Both are same terms.
What's the difference?
Don't get confused. They are perfectly plastic and perfectly inelastic. Both are same thing.
Is there something called just inelastic?
No.
No, but they have given it. So
Where they have given?
look inelastic B point.
Huh?
Look inelastic collision. Just give this separate.
See, there inelastic collision, they have given that kinetic energy before collision and kinetic energy after collision, they will be different.
Okay, same for perfectly inelastic.
Yes.
Could you make me write a small note on it for elastic, inelastic, perfectly inelastic?
You don't get confused about it.
You just make the net value
don't
of E and the difference.
don't get confused about it. You just see what is elastic collision and what is inelastic collision. Don't go over that perfectly inelastic or something. Okay, there is two type of collision. One is elastic, another one is inelastic.
For elastic, we will take E value as 1, and for inelastic, E value is 0.
E value is not 0 for inelastic collision. It varies from 0 to 1. For perfectly inelastic collision, there will be E 0.
Okay. For perfectly inelastic, E 0. For elastic, E is equal to 1. And for just inelastic, we need to find out the value.
Yes.
They will give it to us.
Yes. If even it is an elastic body, see, perfectly elastic, your E will be varying from 0 to 1. Okay? E is 0 is what? 0 is, it is if the body is perfectly inelastic.
Yeah.
Okay? If it is perfectly elastic, then E will be 1.
Yeah.
Somewhere in between, we can say that it is an elastic collision. It is not a perfectly elastic collision.
Inelastic, right?
We can't say whether it is an inelastic or elastic, but we generally say it elastic collision. Okay, we don't call it inelastic collision. Okay.
So there are three types. There are inelastic, perfectly elastic, and there is elastic.
Elastic collision. Okay, so for elastic collision, E will be given to you.
Okay.
Okay.
We will find it out using values of velocity.
Yeah, so incoming velocities and outgoing velocities will give you E. Okay, but E varies from 0 to 1.
Okay.
Now the concept is clear.
Yeah, now it's clear.
Okay, thank you very much.
Thank you. Bye.
Okay then. See, when